Hello everybody and welcome to another video of our course Machine Learning. And this video we're gonna do the practical part of the previous video, which was theoretical part on clustering, specifically two algorithms we learned about, uh, the KNN algorithm and the K-means algorithm. So I prepared some code here we're gonna do together. So first let's start with the K-means algorithm. First, we need to create some fake data, which I prepared here. I created like 50 observations and separated both of them so they be totally separate. I'm gonna show you better than talking. So yeah, so you can see here that these two clusters are separated. You can guess that they are the clusters. I did that so I show you exactly how the algorithm works, and actually it's going to be easy for the algorithm to specify that this is one cluster and this is the other cluster. So let's see how we do that. So first first let me tell you about something called the function k-means, which is a function provided by R. That's why I love R. I always tell you that it's really easy comparing to other languages that don't have like pre-built functions in it. So this k-means function takes only the observations, our x, the number of k's, that means the number of clusters we're gonna predict, chosen by the user, of course. In this time we're gonna choose 2 because if you remember our plot here, you can see that our data is like obviously gonna be 2 clusters, so there is no point of choosing 3 clusters. So yeah, then and start 20. What does that mean? So you know that in K-means algorithm we're gonna choose random centroids, right? So by doing that, by choosing, like, if we don't put that, if it's like equal, that means it's gonna be equal 1. That means from the first time we choose random centroids and that's it. And then we start iterating until we get our cluster and that's it. But in this k-means with n start equals 20, that means we're gonna like have random initialization of the k-means of the centroids 20 times. That means the bigger the better, because if we have 20 times, the R gonna choose the best one, the best representation, and give it to us as a result of that. So it's really important to choose a bigger number than 1. The bigger the better. And of course, if it's too big, the algorithm gonna like take too much time, especially if you are dealing with big data. So you have to think about that. But always the bigger the better. And yeah, then after that, let's see the clusters and plot them. So here the plotting, we just give it the data x and colorize the data given the clusters. So cluster plus 1. This call, yeah, the colorize the data with different colors. So one of them gonna be red because let me show you here. So you can see that these are all our data points, the 50 data points I told you about, and all of these are in the cluster number 1, and all of these are in the cluster number 2. So given this, sorry, this is my preparation for your Python for clustering. Not yet, you don't want to see it yet. So So yeah, here is gonna be 2 for the class number 1 and 3 for class number 2. So we have different colors for different classes, and this is just like the naming and the labeling. We're not gonna put anything for the labeling and so on. So let me show you all of this. We already executed the other one. Okay, as I told you, you can see here the algorithm predicted, like with our k equals 2, predicted the green cluster and the red cluster, and it looks pretty fine. It looks great actually. So yeah, okay, so next. So this is the k-means algorithm. You see, it's really easy with R. With R, everything looks so easy because it does everything for you, so you don't need to worry about that. Now, let's go to the KNN algorithm. It's a little bit more complicated. Let's see. So first, we're gonna use the library AISLR. If you remember the data we used last time for predicting stock market, this time also we're gonna predict stock market, but with the KNN algorithm. So with unsupervised learning, if you can say that, because it's semi-supervised learning. Actually half. And by the way, we're gonna also use the library class. Why? Because it's in the library class we have the KNN function. So if you want to use the KNN function, we need to use that library. You don't need to download anything because all these libraries are already pre-built in R, so you don't have to worry about that. Inside the ISLR library, we have the table weekly, which we are going to use. So I'm gonna print for you the values that we're gonna have in weekly. So we have year, lag 1, lag 2 until 5, like we have last time. If you didn't watch last time's video, so you can go back and watch it. Yeah, so we also gonna predict the same thing, which is direction. Is our stock market going up or down? So we buy or sell. So it's really important task, and it has a lot of money. I showed you before this function attach, which allow us to use these names of weekly without like typing weekly dollar and then the name. So it saves us a lot of time. So what do we need to give for the KNN algorithm? We need to give it the training data, the x's, the values that we are going to classify in cluster. That means the test data. You can call it the test data. And then using the test data, we're gonna, of course, very important thing, which is see our model, how many times gets it right, how many times gets it wrong. So we improve it if it's not good enough. And the clusters of the given test data to verify how good is the model, of course, because like how to know that the model classified the test data right or wrong. And k, also I told you in the video last time that the user need to provide the k. In this time with KNN algorithm, the k means how many neighbors we look at to classify each data point. Yeah, number of neighbors, you see. Am I wrong? Yeah, I'm getting it right. Anyway, I made a mistake here, but it's wrong right now. So so first, the training data. Our training data is gonna be all the data before the year 2009. where we're gonna get leg 2, which is day 2. So this is gonna be our training data. We take it as a matrix, and this function, I didn't show you this function before, I think. So this is your first time. This function is to create, we actually saw a matrix without this. We saw it like that, but I never showed you it like that. So we take it as a matrix. We take this data as a matrix, and for test data, we take all the other data. So we take the information before 2009, before the year 2009. We use it for training, and we test our model with all the data from 2009 and up. By the way, this is weekly data, not exactly the same data we had last time. Yes, the same structure, but not exactly the same data we had last time, because last time I think the newest year was like 2005. It was from 2001, 2005. There was no 2009. So be careful about that. We are taking the weekly data. So we take the directions of our training and the directions of the test data. Then let me give that to the R. Then we're gonna go to the next. So we give it directions. Now we apply the KNN algorithm. From where did we get this function? It's not like just like that. We need to import the library class. Don't forget that. So KNN predicts the KNN function. We give it, as we said, the training data, the tests, and the directions for the training. And then k equals 1. That means we see it one neighbor by one. That means we see it that's like we see the closest neighbor, the closest one neighbor, and we classify it as the same. We give it the same classifications for this closest neighbor. So we did it. Now, okay. Now we need to see the accuracy of our model, like we did previously. The easiest thing is just to print a table and see where our model was right and where our model was wrong. So this is the table. You can see that 21 times our model prediction says it's down, and the real direction was down, yes. And 30 times our model says it's down, but it was up, so our model was wrong. And then 22 times our model was right when he says up, and 31 times it was wrong. So you can see that mostly our model is wrong in predicting, and you can actually verify this by calculating the mean or just simply using the function mean, or just like you can just divide this, you can like this plus this, this divided by this plus this, and you calculate the mean, or just use the function mean. 0.5, that means exactly half. So half of time our model was right, which is not good. Like you can say it's not really good. How can we improve that? How can we improve that? I always like to ask you these questions. I hinted it here. The answer, just play with k. What do we mean? I told you in the previous video, in the theoretical video, that maybe sometimes choosing bigger k give you better performance. So here we are, like the nearest neighbor we are choosing is kind of only one. But what if we see like more than one neighbor? Maybe we can see like 3 neighbors. So we just predict this. Let me take it all and put it here, so you can find it later, because the code gonna be provided with the video. So what if we use 3 neighbors? You see, our model is way better, almost 55%. So you can see that our model got really better than before with 3 neighbors. What if we use 4 neighbors? I just want to show you that the result is always different if you use different neighbors. The model got even better, almost 57%. So it's even better. So let's see 5 neighbors. Now the model got worse. That's what I was looking for. So to get you the idea that not always more neighbors that means better performance. There is like some number of neighbors where it's there, like you cannot add more. So the number here is 4. So remember, here we found it 4. And when you are developing your own model on your own data, you just need to do that, like add the number k until you have like the better performance, the better percentage. So we found out that 4 is the best one, and so we're gonna keep it 4, as you can see here. Maybe you can by the way, you can like see here that it was 4 and it was almost 56%, 57%, and here it's also 4, but it's less. Why? Because there is some kind of randomness, which is initializing our data. You remember that initializing the data is always random, so that's why it's different here and here. How do you, if you want like to have only one initialization of data and keep it like that, so you don't have randomness like this, you just add this function seed, for example 1. Did I do something wrong? I don't really remember, but I'm gonna show you in the next video. I think it was seed. I'm not really sure. Maybe KNN seed. I don't know really. I'm stubborn. No, I don't remember. But anyway, you can look it up. I'm having my moment. So you can look at it. There is like some kind of function seed, so you can like fix your data and get rid of the randomness. So yeah, this was our video on R about KNN and k-means algorithms, and hope you understood it, and see you next video.